Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying different integrals lecture 2. In this lecture we'll be talking about property 4, property 5 and property 6. Okay. So let's begin our lecture with one of the most important property of different integrals, that is property 4. It says integral a to b fx dx equals to integral a to b f of a plus b minus x dx, right? So basically we can simplify our integral with the help of this property by rewriting it like this. Okay. Now, we won't be deriving this property, but we'll see when we have to consider this property. We have to consider, not use it. We have to consider this property based on few trigger points. Okay. So we'll be having two conditions. So the first condition is a plus b equals to pi by 2. That is our first trigger point. Second trigger point would be b equals to minus a. So basically, if we have integral like a to minus a or x to minus x, something of this sort, right? If we have something of this sort, in that case, that would be a second trigger point that we have to consider this property, right? We might be using some other property, but these are the two trigger points based on which we have to consider this property. Okay. And now let's solve this example. We have integral pi by 6 to pi by 3 root sin x dx divided by root sin x plus root cos x. Now we can see that pi by 3 plus pi by 6 is nothing but pi by 2, right? So we can consider using property number 4, right? So let's say this is our I. So we can rewrite I with the help of property 4 as integral pi by 6 to pi by 3 under root sine of a plus b minus x, that is pi by 2 minus x, divided by under root sine of pi by 2 minus x plus under root cos of pi by 2 minus x dx, right? So I becomes integral pi by 6 to pi by 3. This actually becomes under root cos of x divided by under root cos x plus under root sin x dx, right? Now you can add these two i's, this one and this one, right? If you add both of them, we'll be getting integral pi by 6 to pi by 3. This would become under root sin x plus under root cos x divided by, we have the same denominator, we'll be getting under root sin x plus under root cos x dx. So this and this gets cancelled out. We have got our answer, right? And now let's solve one more example. We have integral minus pi to pi x sin x dx divided by e raised power x plus 1. Now I can see that we have minus a to a format. So basically we can again consider using property number 4. So let's say this is our I. So we can rewrite I with the help of property 4 as integral minus pi to pi 0 minus x, basically a plus b minus x sine of 0 minus x divided by e raised power 0 minus x plus 1 dx, right? Now this becomes I equals to integral minus pi to pi. This is minus x and this is sine of minus x. What is sine of minus x? Minus sine x. So this becomes minus sine x. Now minus x into minus sine x, it becomes x sine x dx divided by, this is e raised power minus x. We can write this as e raised power x plus 1, right? If we take LCM over here, we'll be getting 1 plus e raised power x divided by e raised power x. Now this can go over here. So this becomes like this. Okay. Now if we add both of these I, so we'll be getting 2i equals to integral minus pi to pi. Okay. So we can take x sin x is common. So x sin x becomes common and we're left with e raised power x plus 1 dx divided by, this is common in both. So we're getting 1 plus e raised power x. Okay. Now this and this gets cancelled out. Now we are left with this standard integral. Okay. X sin x. We're going to have to use by parts over here. Okay. And now let's solve one more problem. We have integral minus pi by 4 to pi by 4 tan square x dx divided by 1 plus e raised power x. Okay. Now we can see again a pattern of minus a to a. So we can consider using property number 4. Okay. So let's say this is our I. So I can be rewritten as minus pi by 4 to pi by 4 tan square 0 minus x, basically a plus b minus x dx divided by 1 plus e raised power 0 minus x, right? Now this is nothing but e raised power minus x and this is nothing but tan square x only, because tan square minus x is nothing but tan square x. Okay. Now if we rewrite this, we'll be getting I equals to minus pi by 4 to pi by 4. This becomes tan square x dx divided by 1 plus 1 upon e raised power x. If we take the LCM, we'll be getting e raised power x plus 1 divided by e raised power x. Now this e raised power x goes over here. It becomes e raised power x tan square x dx divided by e raised power x plus 1. Okay. If we add both of these, we'll be getting 2i equals to integral minus pi by 4 to pi by 4 tan square x taken as common we'll be getting e raised power x plus 1 divided by e raised power x plus 1 dx. Okay, so this and this gets cancelled out. So what we have got, 2y equals to integral minus pi by 4 to pi by 4. What we are left with, tan square x. We can write it as sec square x minus 1 dx. Now this becomes a very standard integral, right? And now let's solve this last problem. We have integral 0 to pi by 2 sine cube x dx divided by sine x plus cos x. You can see that the summation is pi by 2. So we can consider using property number 4. Let's say this is our I. So I can be rewritten as 0 to pi by 2. This becomes sine cube pi by 2 minus x divided by sine of pi by 2 minus x plus cos of pi by 2 minus x dx, right? So this becomes I equals to 0 to pi by 2. This is nothing but cos cube x dx divided by cos x plus sin x. If we add both of them, we'll be getting 2y equals to integral 0 to pi by 2 sin cube x plus cos cube x divided by sin x plus cos x, right? Now we can use a cube plus b cube over here. So this would become 2y equals to integral 0 to pi by 2. This is nothing but sin x plus cos x multiplied by sin square x plus cos square x minus sin x cos x. Okay, divided by sin x plus cos x. So this and this gets cancelled out. We are left with sin square x plus cos square x minus sin x cos x. Now this is nothing but 1 only. So 2y equals to 0 to pi by 2, 1 minus sin x cos x dx, right? If we multiply 2 and divide by 2 over here, we'll be getting 2 sin x cos x divided by 2. And this is nothing but sin 2x. Now it becomes very simple. Okay. And now let's talk about property number 5. We have integral minus a to a fx dx equals to integral 0 to a fx plus f of minus x, which becomes 0 when the function is odd function and becomes 2 times 0 to a fx dx when the function is even function. And again, we won't be deriving this property. We just have to remember this property. Now, if you remember, we talked about minus a to a format in property 4 as well, right? And we said that whenever you see this kind of format, you have to consider using property 4. You don't have to necessarily use property 4. You have to consider using property 4, right? So similar thing over here. Whenever you see minus a to a format in the integral, you have to consider both property 4 and 5, and sometimes you have to choose which one to use. Sometimes you'll be able to use both of them to find the answer, but sometimes you'll have to choose which one to use to find out the answer. Okay. And now let's solve one problem. We have integral minus 1 by 2 to 1 by 2 g of x plus ln of 1 plus x divided by 1 minus x dx, right? Now, unlike property 4, we don't have to do the summations every single time we apply the property. We can directly mark it as 0 when the function is odd function. We can directly write it as like this when the function is even function. All we have to care if the function is odd function or even function. That is what we want to do in case of property 5, right? Now, if we talk about this function, can we say g of x is odd or even? No, we cannot do that. We cannot comment on that. Can we say if this function is odd or even? We can do that definitely. So fx equals to ln of 1 plus x divided by 1 minus x, right? Now, if we write down f of minus x, that would be ln of 1 minus x upon 1 plus x, right? Now, this can be written as ln of 1 plus x upon 1 minus x raised power minus 1, right? Now, with the help of log property, we can shift this minus 1 over here. So, this becomes minus of ln of 1 plus x upon 1 minus x. Now, this is nothing but minus of fx. So, basically, f of minus x equals to minus of fx, basically an odd function. Okay. So this function is an odd function. So basically this becomes 0 straight away, right? So this becomes 0. Now we are left with integral minus 1 by 2 to 1 by 2 gi of x dx. Now we know that gi functions are discontinuous or non-differentiable at integers, right? So we have to break down this function into two parts, right? Now gi function can be defined as minus 1 when x belongs to less than 0, bigger than equals to minus 1 by 2, and when x is less than 1 by 2, bigger than equals to 0, it would be 0 only, right? So we can break down this function into two parts, right? So this integral becomes minus 1 by 2 to 0 minus 1 dx plus 0 to 1 by 2 0 dx, right? So this becomes our final answer. Okay. And now let's solve this question. If f is an odd function, then evaluate I equals to integral minus a to a f of sin x dx divided by f of cos x plus f of sin square x. Now in this case, you have to just identify if the function is odd function or even function if you have to apply property 5. So I'll keep this as homework. You just have to check if the function is odd function or even function. Okay.